The addition of molecular bromine to an alkene in a non-participating solvent results in the formation of a saturated trans-dibromide product. The isolation of only the trans isomer or isomers provides evidence for a stepwise addition pathway that does not include the formation of any open carbocation intermediates. This reaction is used as a colorimetric test for alkenes, as the deep orange color of the bromine is lost when addition occurs and the dibromide is formed. Since only the trans stereochemistry is observed in the products, the formation of an open carbocation is precluded. Any such planar intermediate would also lead to isolation of some of the cis dibromide. The mechanism most likely occurs with concerted addition of bromine to the pi bond and synchronous loss of a bromide leaving group to produce a three-membered bromonium ion intermediate. In this structure, each atom obeys the octet rule. The strained bromonium ion may then only be attacked by bromide nucleophile from one direction, thus providing the trans stereochemistry. Although molecular bromine is a non-polar material, it is possible to induce a dipole if bromine is placed in the presence of an electron-rich alkene. The electrophilic end of the bromine molecule may then add to both carbons of the pi bond with concerted loss of a bromide anion through a three-membered ring transition state. Since bromine is a large atom and it has lone pairs, it is capable of bonding to both carbons at the same time, making the bromonium ion more stable than the carbocation alternative. Complete formation of the three-membered ring results in breaking of the weak bromine-bromine bond and the formation of the cyclic bromonium ion and a bromide nucleophile. The bromonium ion intermediate ultimately explains the formation of only the trans-dibromide products. In this particular example, the intermediate happens to be the mesoisomer. In the second step, the bromide nucleophile attacks the strained bromonium ion from underneath in order to donate its lone pair into the appropriate anti-bond. This results in the trans stereochemistry observed in the product, and since the symmetrical meso-intermediate may be attacked at either carbon, a racemic mixture of dibromides results. Overall, treating an alkene with molecular bromine results in trans-dibromide products only. The cis isomers are not formed since a strained bromonium ion is created in order to avoid an open carbocation. In the bromonium ion, each atom involved always has an octet of electrons, thereby making it more stable than a carbocation. Ultimately, the addition process is thermodynamically viable since a pi bond and weak bromine-bromine bond are swapped for two stronger carbon-to-bromine sigma bonds.